assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This problem involves a physical pendulum that is made from a solid disc that has a radius of 2.35 centimeters and is supported by a pivot located 1.75 centimeters from the center of the disc. We're trying to figure out what the period of the resulting simple harmonic motion is going to be. So we're going to use the equation period equals 2 pi times the square root of inertia divided by mass times gravity times the length of the pendulum. Now in this case, the inertia is the total moment of inertia and the mass is the total mass of the pendulum. We have to find the rotational inertia about the pivot point, and the inertia about the center of the disk. Now, the inertia about the center of the disk, so inertia ICM, is equal to the mass times the radius squared divided by 2. And then using the parallel axis theorem, we can find that the total inertia is going to be our inertia around the center plus the mass times h squared. And in this case, our h equals d. So the distance between the pivot and the center of the disk is going to be our h value. So in other words, we can write this equation as inertia equals mass times radius squared divided by 2 plus the mass times our distance squared. Okay, so plugging this now into back up into our period equation here, we have period equals 2 pi times the square root of mass times radius squared divided by 2 plus mass times distance squared divided by mass times gravity times distance. And we can simplify that even further to just 2 pi times the square root of r squared plus 2d squared divided by 2gd. Then we have our values over here. So we're going to take this over and plug in our known values. And so we will have 2 pi times the square root of 2.35 centimeters squared plus 2 times 1.75 centimeters squared divided by 2 times 980, which is our gravity taken from meters per second squared turned into centimeters per second squared, since our other values are also in centimeters, times 1.75 centimeters, giving us a period of 0.366 seconds. So that is the period of this pendulum.